With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello, so question is saying this, which one is most reactive towards AgNO3, right? So we have to find out that in which of the following compound, which one is most reactive when we react with AgNO3, right? So actually here there are alkyl halide, right? So alkyl bromide, right? So here, so what will happen, right? So now you can see here, this is R, if I'm writing a general equation, right? So that is RBr, right? So RBr, which is treated with AgNO3, right? So which is treated with AgNO3, right? So there is a formation of AgBr, right? So there is a formation of AgBr, right? So AgBr, right? And along with this, there is a formation of, first it will convert into R positive ions, right? So R positive ions, and then if this is stable, right, then it will react with NO3. That is negative part from here. That will become RNO3, right? So RNO3, right? So now the reaction will depend upon this intermediate, right? That means if this is stable, right? So that means this particular compound will react most effectively, right? So will react very fast, right? So now we have to see it, right? So if we talk about the option A, right? So if we talk about the option A, in option A we have that is nitrogen A, right? So that is nitrogen A, and these are two ethyl group, right? So these are two ethyl group, right? And one is this like Br, right? Now what will happen when we react with AgNO3, right? So when we react with AgNO3, then first what will happen, right? So what will happen? First there is a formation of carbocation, right? So first there is a formation of carbocation, right? Now you can see here, this is R2 ethyl group, right? These are two ethyl group, right? And this is primary carbocation, right? So this is primary carbocation, right? So but here you can see this, there is a lone pair also, right? So there is a lone pair also, right? So this lone pair is, or you can say that this carbocation is stabilized by this lone pair, right? So that means plus M effect is taking place here, right? So plus M effect is taking place here, right? So that means this carbocation is stable, right? So this carbocation is stable, right? So now that means reaction will take place, right? So reaction will take place, right? So with AgNO3, right? And if we talk about the option B, right? If we talk about the option B, here what will happen? There is oxygen over here, right? And there is bromine here, and there is also bromine here, right? Not bromine, right? This is simple ethyl group, right? So now what will happen? So when we carry out the reaction, so first there is a formation of intermediate, that means carbocation, right? So and this becomes a carbocation, right? So this becomes a carbocation, right? Similarly here you can see this is also resonance stabilized, right? So this is back bonding stabilized because this has a vacant orbital, right? So that means there is also plus M effect, right? So that means this is also react very fast, right? So now but here you can see this in both this compound, right? In this both the electronegativity of, if I'm talking about the electronegativity of oxygen is very high, right? So is very high as compared to electronegativity of nitrogen, right? So that means the lone pair of oxygen will take a time, right? So will take a time because the lone pair does not want to go from this side, right? So that means because oxygen is very electronegative as compared to nitrogen, right? So that means these lone pair will take part in, you can say that, in stabilization, right? So that means this will stable first, right? So because of low electronegativity of nitrogen as compared to oxygen, right? So that means if you compare in both these compound, so that means this compound will react fast with AgNO3, right? So now let's see another option here. Another option is that is here, you can see here, that is here benzene ring also there, right? So that means here benzene ring also there, right? So if we talk about option C, so this is our benzene ring, right? So this is our benzene ring, right? So let's say this is our benzene ring, and this is nitrogen, right? So this is nitrogen, and this is our alkyl part, right? So alkyl part, bromine here, and these are ethyl part, right? So now what will happen here in this particular case, right? So the reaction will be look like this, right? So that this becomes a carbocation here, right? So this becomes a carbocation here, right? But in this case you can see this, the lone pair of nitrogen are involved in conjugation with the, you can say with benzene ring also, and also with this carbocation, right? So also with this carbocation, right? That means there is less availability of the lone pair for this stabilization, right? So that means this is less stable as compared to this, right? So as compared to this, right? That means I can say this will not react fast as compared to this option A, this particular compound, right? So and if we talk about the option D, right? So if we talk about the option D, so you can see here in case option D we have this a benzene ring over here, right? So we have benzene ring over here, right? And this is our nitrogen, right? So this is our nitrogen, but here you can see this is our bromine, right? So this is our bromine, and this is our ethyl group, right? So now what will happen here? Here when carbocation will take the carbocation formation will take place. So the reaction will be look like this, right? The reaction will be look like this. So you can see here, this is like this, right? So this is like this, right? So this is primary carbocation and this is, right? So now you can see here, this is not resonance stabilized, right? So that means this is only primary carbocation, and which is not stable, right? So which is not stable, right? So this cannot be our answer, right? So this cannot be our answer, right? And if we talk about the A, B and C, right? So because here in the C, there is a lone pair is also involved in the conjugation with engineering, and so that means there is a less availability of the lone pair, right? So this cannot be our answer, right? So that means this cannot be very reactive, right? So because this intermediate is not stable as compared to A and B, right? So now come to the A and B, right? So as we know that in the A and B, this intermediate is very stable, right? So because the lone pair is available, right? So because here the electronegativity of lone pair, electronegativity of the oxygen will inhibit this, you can say this lone pair to participate in this conjugation, right? So that means this cannot be our answer, right? So option A will be the right answer, right? Option A will be the right answer, right? So in this way, I can say that this particular compound will be the most reactive toward AgNO3, right? So hope this answered your question. So thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.